Hello everyone, I'm Jiang Zhou from the First Affiliated Hospital of Nanjing Medical University. It's a privilege to share our work on diagnosing DON using advanced MRI techniques. The topic of our work is multiparametric MRI for diagnosing DON, added value of MTI. I've structured my presentation into 4 parts, including introduction, materials and methods, results, and conclusion. First, the introduction part. DON, a vision-threatening complication of TAO, affects about 3% to 8% of patients with TAO. Although its definitive pathogenesis remains unclear, it is generally attributed to optic nerve compression, stretching, and ischemia caused by orbital apex crowding. DON usually presents with an insidious onset and rapid progression, resulting in obvious visual impairment and even permanent visual loss. Therefore, timely diagnosis is crucial for implementing effective interventions and improving patient prognosis. To date, the gold standard for the clinical diagnosis of DON has not been established. Visual impairments are commonly adopted ophthalmic indicators for diagnosing DON. However, these symptoms may exhibit similarities or partial overlap with those present in patients without DON, leading to delayed diagnosis in clinical practice. With advancements in imaging techniques, orbital MRI has emerged as the preferred tool for diagnosing DON. Conventional T2-based imaging and DWI are widely used to explore the imaging markers of DON. However, none of the aforementioned techniques directly reflected ON neuronal injury, which are possible pathological changes associated with ON compression. MTI, an advanced quantitative MRI technique, can provide information on the proton magnetization exchange between free water and the macromolecular bound water. The derived MTR reflects the concentrations of macromolecules in physiological environments, such as lipid-rich myelin shear of the ON. MTI has been used to assess myelin shear damage and axonal loss in several ON diseases. However, to the best of our knowledge, data on the application of MTI to detect neuronal injury in the ON of patients with DON are still lacking. Given the successful application of MTI in various ophthalmic diseases, we hypothesized that alterations in the myelin shear and the axons of the ON in patients with DON could also be detected and quantified using MTI. Therefore, we aimed to investigate whether the MTI values of ON differed significantly between patients with TAO with and without DON. We also investigated whether MTI offered additional value in conventional T2WI and DWI assessments for the diagnosis of DON. Next, the materials and method parts. A total of 149 patients were included in this retrospective study. Patients with and without DON were divided into training and validation cohorts, respectively. For each enrolled patient, a standardized clinical evaluation were conducted. All ophthalmic data were analyzed per eye as the unit. MRI examinations were performed using a 3T MRI system. The orbital MRI protocols included coronal MTI, FST2WI, and DWI. All quantitative parameters were measured in eye units, including MTR, SIR, EDC of the ON and the MMI. All statistical analyses were performed using the SPSS software and the MedCalc. I won't elaborate on the conventional statistical method, but will explain the key statistical methods in detail. The MRI-derived parameters with p less than 0.05 in the univariable analysis of the training cohort were selected for multivariable logistic regression analysis using a forward condition selection method to identify independent imaging predictors of DON. Binary logistic regression was used to combine the identified independent imaging predictors and construct a multi-variable model. ROC curve analysis were used to evaluate the performance of the imaging predictors and the multi-variable model combining imaging predictors for diagnosing DON. Next, let's move on to the results section. Clinical and demographic characteristics showed no significant differences between the training and validation cohorts. This table also presents comparisons of clinical and demographic characteristics between the DON and the non-DON group in the training and validation cohorts, with consistent trends observed in both cohorts. In the training cohort, patients with DON exhibited significantly lower MTRs, higher SIRs, lower ADCs, and higher MMIs than patients without DON. Detailed comparisons of the imaging parameters between the DON and the non-DON groups in both cohorts are presented in this table. Multivariable logistic regression analysis results indicated that MTR mean, ATC mean, and MMI were independent predictors for DON. Then a multivariable logistic regression model was constructed using all three independent predictors. ROC curve analysis was used to evaluate the diagnostic performance of MTR mean, ADC mean, MMI, and the multivariable model in diagnosing DON. In the training cohort, the multivariable model performed the best, followed by MMI, MTR mean, and ADC mean. In the validation cohort, the multivariable model still showed a significantly higher AUC than the ADC mean. However, the differences between the multivariable model and the MTR mean and MMI did not reach statistical significance. In addition, there are significant correlations between MRI-derived quantitative parameters and clinical characteristics. Finally, let's make a summary. In conclusion, our preliminary study confirmed the feasibility of applying MTI to evaluate DON because of its ability to directly reflect the myelin shield damage and the axonal loss in ON. MTI may potentially serve as a novel complement to conventional MRI in diagnosing DON. That's all for this study. Thank you for your attention.